Let's find the components of a given vector in three-dimensional space. To begin with, we consider a 3D coordinate system with the origin at O. Here we have the x-axis, which will be OX. Then we have the y-axis denoted by OY, and we have the z-axis denoted by OZ. Next, we have the unit vectors I cap along x-axis. We have j cap, that's the unit vector along y-axis, and we have k cap, the unit vector along the z-axis. Now, let's say we have a point in space and it's denoted by P with coordinates x, y, and z. Now here, our goal will be to find out the position vector of point P. All we have to do is join the origin and the point P with the help of a directed line segment going from O to P. Now, to find out the position vector of point P, first we'll start from the origin O. Now there are several paths that we can take to reach point P. So here I have considered a cube. So let's say first we start from the origin and then we move some distance along the x-axis, let's say, and stop at point A. Now from this point A, we're going to move along the y-axis. Let's say we stop at the point B. Then from point B, we can move towards point P, and that's how we can reach point P. There are several other ways. We can start from the origin, move some distance along the y-axis, then move some distance along, let's say, move along the y-axis to meet at the point C. From point A, we move along the x-axis to reach point B, and from point B, we move upwards to reach point B. So we can find out other ways as well. For this particular problem, I'm going to choose the path OA, AB, and BP. Now for this, let's call this point D. Here we're going to make some assumption. Let's say the distance from point O to the point A along the x-axis is going to be x units. If we start from the origin and move to the point C along the y-axis, we're going to call it y distance. That means we say y units, we moved from the origin to the point C along the y-axis. Then we have OD. OD, we're going to consider it to be z units. Okay. Now we're going to take the path. The path that we'll be taking is OA followed by AB and then reach the point P via BP. Now since I cap, j cap, and k cap are the unit vectors along the x, y, and z axis, we have OA vector represented by the magnitude x multiplied with the unit vector along x axis. Then OC vector is going to be y times j cap, and OD vector is going to be z times k cap. Okay. Now first, what we'll do, we'll join point O and point P with the help of a directed line segment going from O to B. So what we'll do first, we will consider the triangle OAB. Now OAB is going to be, we're going to use the vector OA and the vector AB to represent OB. Now OB vector, that's simply going to be the sum of OA vector and AB vector. So here we have used the triangle law of vector addition. However, we know that OABC is a parallelogram and the opposite sides are equal. Or we can, other words, we can say that this is a cube and the sides of the cubes are equal. So here AB vector is going to be equals to OC vector. So in place of AB vector, we can write OC vector such that we have OB vector given by OA vector plus OC vector. We're going to keep it aside for the time being. Let's label this as number 1. Next, what we'll do, we'll consider the triangle OBP. So here we will consider the vector going from O to B, then we'll consider the vector going from B to P and the vector from O to P. So let's use the triangle. Now, in triangle OBP, again using the triangle law of vector addition, we have OP vector given by OB vector added to BP vector. Now using 1, we can replace the OB vector with OA vector plus OC vector. However, BP vector, now BP vector is going to be equals to OD vector. So here we can replace BP vector with OD vector since BP vector equals to OD vector. So now we have the vector OP expressed as a sum of OA vector plus OC vector plus OD vector. We've already considered OA vector to be x times I cap, OC vector to be y times j cap and OD vector to be z times k cap. So here we have successfully expressed the position vector of the point P having coordinates x, y and z as the vector xi cap plus yj cap plus zk cap. Next, we'll try to find out the magnitude of OP. So here we'll start with the triangle OAB. Now in triangle OAB, the OA is going to be perpendicular to AB. So that means OB is going to be the hypotenuse. So we have OB squared equals to the sum of the squares of the other two sides. So that means OB squared will be OA squared plus AB squared. Again, we can use the fact that AB is going to be equals to the length OC. So here we will get OA squared added to OC squared. This is going to be OB squared. Next, we're going to consider the triangle OBP. Let's go to the figure. So here we have the triangle OBP. So here OB is going to be perpendicular to PB. That means OP is going to be the hypotenuse, and then this square of the hypotenuse is going to be equals to the sum of OB squared and BP squared. So we have OP squared equals to OB squared plus BP squared. But we know that BP, the length of BP is going to be the same as the length of OD. So we have OD squared replaced in place of BP squared. So we get OB squared plus OD squared. Let's write it down, since BP squared equals OD squared. Right. So this is a BP. Now OB squared, we can use this value. So in place of OB squared, we have OA squared plus OC squared added to OD squared. So this is a OP squared. Now we'll take the square root on both sides, and that's going to give us the square root of OA squared plus OC squared plus OD squared. Now here we are only concerned with the magnitude. So the magnitude of vector OP, that's going to be equals to, we'll take the square root. Underneath the square root, we now have x squared plus y squared plus z squared. Thus, if a point P in space has coordinates x, y and z, then its position vector, which is denoted by r vector, is xi cap plus yj cap plus zk cap, with magnitude given by the square root of the sum of the squares of the coordinates.